Okay, so here we are with some more Unit 4 trigonometry. Hopefully this gets you ready for the quiz. Most of this deals with Section 2 and 3 of Unit 4. We're talking about reciprocal trig functions, secant, cosecant, cotangent. We're going to do a couple problems where we try to determine or define all 6 trig ratios from some given information. And last, we're going to graph with various periods and frequencies. So starting out here, looking at our reciprocal trig functions, we have secant of 3 pi over 4. And this still begins on the unit circle. Goes back to knowing your unit circle and how well you know your unit circle. So if we're thinking secant, remember here definition-wise, okay, secant is the reciprocal of cosine. All right, cotangent is the reciprocal of tangent, and cosecant is the reciprocal of sine. Okay, so first things first, to know what secant is, we have to know what cosine is. So what is the cosine, okay, of 3 pi over 4? And the answer there for cosine of 3 pi over 4, we're in the second quadrant. 3 pi over 4 is right here, okay? The cosine, the x value, is going to be negative root 2 over 2. Now, if you want to find the secant of that, okay, we have to take the cosine value and find its reciprocal. So we flip the fraction, so negative 2 over root 2. Now that'll get you some credit on a quiz or a test, but not full credit. Full credit, we would have to rationalize that denominator by multiplying by root 2 over root 2. So the actual cosecant here, we'd have negative 2 root 2 over 2. And here the 2's cancel, so we end up with negative root 2. So the secant of 3 pi over 4 ends up being negative root 2. Next, we'll try cotangent, and just a little review here, an angle bigger than 2 pi. So 11 divided by 3 is 3, and the remainder is 2. So 3 is odd. That means we're starting at pi. So we're here at pi, and we're going 2/3 farther. So 1/3, 2/3 farther. So we're actually, right here, we're actually at 5 pi over 3. So we're trying to figure out the cotangent of 5 pi over 3. Okay? But to know the cotangent of 5 pi over 3, we have to know the tangent. Okay? Or we could also refer back to our definition here of cotangent as cosine over sine. So the cosine of 5 pi over 3 is 1/2. The sine of 5 pi over 3 is negative root 3 over 2. Now we will never divide by a fraction. Instead, we will multiply by the reciprocal. When we do that, the 2's cancel each other out. So we're left with 1 over negative root 3. Okay, that'll get you some credit. Full credit, though, would be the rationalized version. Okay, so the cotangent of 11 pi over 3, when rationalized, ends up being negative root 3 over 3. Last, we have the cosecant of negative 5 pi over 6. Now we're talking about a negative angle. All right, so unit circle, negative angle, we're going backwards, 5 pi over 6. So that puts us at 7 pi over 6. You could also go to 5 pi over 6 and flip it over the x-axis. Okay, so we're thinking about the cosecant here of 7 pi over 6. But again, cosecant's not really what we're thinking of first. We're thinking of sine. So what is the sine of 7 pi over 6? Okay, the sine of 7 pi over 6 is negative 1/2. All right, so the cosecant then would just be the reciprocal of that. That ends up being the easiest of the 3. So the cosecant of negative 5 pi over 6 equals negative 2. That's a negative 5, sorry. All right, and moving on, determine the trig ratios from the given info. So, given that tangent of theta is 4 over 3, and that theta is between pi and 3 pi over 2, to find all 6 trig functions. These problems always begin with us, first of all, determining what quadrant we're in. So pi and 3 pi over 2 places us in the third quadrant. Okay, the tangent is 4 over 3. Remember, tangent is defined as y over x. So that means our y value is negative 4, our x value is negative 3. Okay? We would need to find the third side of that triangle, and that third side is going to be 5. 3, 4, 5 is what we call a Pythagorean triple. And from that point, we're going to define all 6 trig ratios. Obviously, you already know one of them that was given, okay? But I'll give you a point if you still define it appropriately, which means nobody should get a 0 on one of these. Plus, if you know that value, you're going to know the reciprocal of that. So the one that we know is 4 over 3, okay, which means cotangent is 3 over 4. And then from that point, we're just defining sine, cosine, cosecant, secant based on our y's and r's. Remember, sine of theta is y over r, cosine of theta is x over r, and then cosecant and secant are the reciprocals. So sine is going to be negative 4 over 5, okay, and cosine is going to be negative 3 over 5, which means cosecant is negative 5 over 4, and secant is negative 5 over 3. That's an easy one, especially when you don't have any denominators to rationalize. But what if you do? So given that secant, theta is 7 over 5, okay, and theta is now in the first quadrant, okay, between 0 and pi over 2. So we're looking at a first quadrant triangle here, all right. And secant, remember, secant here is the reciprocal of cosine. So that means r over x. Okay, so our x value is 5, our r value, or our hypotenuse, is 7. So we need to find the y side. Okay, so 7 squared minus 5 squared equals y squared. So that's 49 minus 25, okay, which is 24 equals y squared, which means y is going to equal 2 root 6. Remember, decimals we do not want. Okay, we do not want decimals, we want reduced, okay, radicals here. So, if I'm going to define all 6 trig functions then, that means the sine of theta is going to be 2 root 6 over 7. Cosine of theta is going to be the reciprocal of my given information, which is 5 over 7. Tangent of theta is going to be y over x, which is 2 root 6 over 5. Okay? And then my reciprocals, cosecant of theta, is going to be 7 over 2 root 6. Secant was given, so everybody should get that one right. 7 over 5. Cotangent, all right, is the reciprocal of tangent, so that's going to be 5 over 2 root 6. Now that's some credit. Full credit, we would rationalize these. So root 6 over root 6. So we would end up with 7 root 6 over 12. And here we would end up with 5 root 6 over 12. The 12 comes from root 6 times root 6 makes 6. 6 times 2 is 12. Next, graphing trig function. So we want to graph 2 times the sine of 4x plus 3. So always start the same way. Label each of my parts. Okay. In this case, my period is a little different. So my amplitude is 2. My b value is 4. My h value doesn't exist, and my k value is up 3. All right. Remember, period is pb equals 2 pi. So p times 4 equals 2 pi. Whoops, p times 4, which means the period equals pi over 2. So that's a short graph here, okay? So period is pi over 2. All right, and it's a sine curve. Up 3, still first, so we go up 3. I do my dashed line, up 3. Sine always begins at 0, 0. Okay, so right here is where it begins. It's positive sine, so it's going up first. First point, last point is at pi over 2. Wow, that's a tight sine curve there, okay? That means my other x-intercept is halfway in between, and that means my max and mins are 2 above, halfway in between, so here and 2 below. So my sine curve is really scrunched down. And I can continue that as many times as I want. Remember, on a quiz or a test, you got to have 1 full cycle, okay? But that's the minimum is 1 full cycle. But again, you can do this as many times as you want. I'm going to actually extend it all the way to 2 pi so you can see what this frequency actually means. Okay, frequency is how often it occurs over 2 pi. All right. And hopefully from this picture you can see it occurs once in blue. Let me go once in red. All right, a third time. Okay, and a fourth time. Frequency is 4. Okay, so it actually occurred 4 times over 2 pi. Next, we have -3 cosine of x over 4 plus 1. Still begin the same way. All right, a value is -3. B value is 1/4. H we do not have. K is down 1. Period we have to find. So P times B is 2 pi. So our period times the phase shift, or excuse me, the frequency of 1/4 equals 2 pi, which means our period is going to be 8 pi. Okay, so this is a little tricky here because of the way the axis is labeled. All right, but let's go down 1 first. Okay, and cosine always begins, well, this is negative, so it's going to be down 3, 1, 2, 3 from there. Okay, that's your 0 point. Your last point would be at 8 pi. Well, I have a bad grid here. Mine only goes to 2 pi, which is 1/4 of the way. So if my last point's at 8 pi, my halfway point is at 4 pi, which means my intercept is at 2 pi. Okay? Same thing here, -2 pi. This is a bad thing here, because I'm not even going to get half my curve, which means I would fail my own quiz. Okay? I have half of a cosine curve here, total. That's not even the half I want. So you see the importance of labeling your axis appropriately. So let's say that I do, whoa, did not want to do that. Let's say that I do label my axis more appropriately than what I have here. All right? So let's say that, let me override this, and let's say that this is 2 pi, 4 pi, 6 pi, 8 pi. So if I do that, I'm going to have 3 below, 1, 2, 3. My last point for cosine appears at 8 pi because my period is 8 pi. My halfway point is 4 pi, which is going to be 3 below. Okay, and then my halfway of halfways are my intercepts, so that's at 2 pi and 6 pi. Okay, and that looks much more like a cosine curve, negative cosine curve there. Okay, hopefully everybody comes ready for the quiz tomorrow. Please review the other video before this one about Unit 4 trig stuff, and we'll see you then.